Hi, I'm Carol Grimes, a mechanical engineering major and team lead of the San Antonio College Motorsports team. As climate change data becomes available and more understood, vehicle manufacturers seek to design more fuel efficient, sustainable vehicles. Our team's research is into a hydrogen fuel cell powered prototype vehicle. In February 2021, our team met for the first time on Zoom. Due to COVID restrictions, we met virtually for a month until we were granted access to the San Antonio College campus. However, we were only permitted to work outside at that time and met in the parking garage. It is here that we met the 2019 team's Odyssey vehicle. We used Odyssey to compete in the Shell Eco Marathon virtual technical inspection. This allowed us to get hands-on with the vehicle and identify areas in which we wish to improve. A large component of fuel efficiency is aerodynamics. We observed when a driver sat in the vehicle, the frame flexed. We also noticed that the outer shell of the vehicle was not rigid. We suspected that the flexing of the frame and the lack of structure in the outer shell would reduce aerodynamics of the vehicle and fuel efficiency. We began work on preliminary sketches for a new frame and outer shell, and at the end of April, we were granted access to on-campus buildings and were able to enter the MESA lab. We initially planned on using a magnesium alloy material for the frame due to the light weight of the material. However, with the manufacturer and supply chain disruptions due to COVID-19, we found that the material was either out of stock or exceeded our budget. We decided to use aluminum tubing as it was more readily available and affordable. The 2019 Odyssey did not utilize a structured frame, and we anticipate that the aluminum frame will alleviate the flexing issue. The other component that we identified as a potential aerodynamics issue, and what I took particular interest in, is the vehicle's outer shell. I had noticed that not only did it lack structure and was showing wear and tear, it lacked user friendliness. Meaning when we were working on the virtual technical inspection, we noticed that it was hard to attach the shell to the vehicle body. The system used on the Odyssey is bolts and wing nuts. The bolt is on the vehicle itself. The shell has holes that should fit onto the bolts, and then a wing nut holds it all together. In practice, we found that the holes on the shell did not meet up with the bolts on the body. I plan on using a quarter-turn fastener system with the new vehicle. These types of fasteners are used in racing vehicles, and this is an example of a quarter-turn fastener similar to what we will be using on the vehicle. To address the lack of structure, a system of 3D printed ribs will be designed. The ribbing will act like a skeleton inside the shell and add stability without adding much weight. I anticipate that the added structure will keep the shell from flexing when the vehicle is in motion, increasing the aerodynamics and fuel efficiency. Looking to the upcoming fall semester, we anticipate the frame design and frame will be completed, and we will begin work on the final outer shell design. Once we finalize an inventor design for the shell, we will use 2-inch thick foam insulation board to make a mold. Sections will be cut using a hot wire device. The prior team had made a hot wire using nichrome wire, commonly used in vape coils, and running electricity through it. I designed 2 new hot wire cutting tools this summer, one to be used for making deep cuts in the material and the other to make smaller, more honing cuts. This is one of my test pieces of foam insulation material. Once the mold is made, we'll be able to manufacture the shell out of either carbon fiber or fiberglass material. We hope that our research can be utilized by future teams to design an urban concept vehicle. Shell Eco Marathon defines the urban concept class as a vehicle that will hold a passenger as well as a driver and follow street legality guidelines. Thank you very much.